the slope.
Find the slope. So remember, pay attention to your increments. So I'm going -4. And then I go 3, 6, 9, 12, 15, 18. Is it 2 or is it 2 lines?
Mine's -4.
It's okay.
Okay, mine.
You guys, it's okay.
I most definitely did something wrong, I think. I don't
So when you were plotting,
know what I plotted weird though.
so over to 22, up to 16, that's good. Over to 14, up to 17. So it looks like your 14 one was off a little bit. Over to 18, up to 17. Yeah, I mean, it looks like just 1 or 2 of them might be off, but it's fine. Okay, so I've got my slope. What's my next step? And guys, remember, your slope may not be the same as mine. It's okay. But it needs to be in simplest terms. So mine doesn't get any simpler than -2/9, right?
Find the y-intercept.
Find the y-intercept. So my y-intercept looks like it is 0, 21. Yours might be different. Guys, how do we know that our slope should be negative? Because it's a negative, like it's declining, right? It's decreasing. Okay, so my equation, my linear equation would be -2/9 x plus 29, excuse me, plus 21.
You are the same one.
Okay, let's take this a step further. What does the slope mean? What does the slope mean? What does it mean, Grace?
When the price goes down, the more miles.
Yeah, so remember, slope is the y info over the x info, right? So this is going to be price over mileage. Because price is my y-axis title, mileage is my x-axis title. So for me, -2/9, that tells me, for my specific scenario, the price decreases $2,000 every 9,000 miles on the car. That's what mine says. So if your slope was negative, somebody give me a different slope than mine. Okay, so -2/6 should be simplified to -1/3, right? So that would tell me that the price goes down $1,000 every 3,000 miles. Yes. Okay, what was yours? Great. It goes down $1,000 every 4,000 miles, right? So that's what the slope means. Okay. What does the y-intercept mean? Yeah.
How many miles?
Starting price, 0 miles. Right? That's what that means. Starting price, 0 miles. Right?
Wait, so what would -1/5 be for that?
So that would be every 1,000, it loses $1,000 in value every 5,000 miles it gets added. So this is 0 miles starting price. I'm going to write this backwards so that it's the x and y. €0 starting price. How are we doing?
I did this a lot more yesterday.
Well, because we added a little more to it today. Okay. Avery? Sure, hurry back because we're moving on. Okay, turn the page. Like I said, we got to keep moving. Woo. Now we're going to use our graphing calculators. You don't know you have it. But
Oh yeah, I never bought it.
nope, it's on your iPad.
Wait, what
So right here, no, I want you to use the iPad one because I can't help you if you don't use the iPad one. So you should have this Desmos right here. It looks like this. Everybody should have this Desmos. Does everybody have that on their iPad?
Yeah.
And then when you click on it, it should open up and it looks like this. Hold on.
Mine too. I'm on Safari. Mine on Safari. Yeah, mine goes on Safari.
So you guys, oh, okay.
Should we download it from App Portal?
No, it probably won't be there. So is this what yours looks like then?
Yeah.
Okay, so let's see. Go to graphing calculator. There you go. So Desmos graphing calculator. That's where you need to be. Okay. Now you're going to click on the three little lines. So Desmos graphing calculator, three little lines. I'm going to make notes of this for tomorrow because I won't be here tomorrow. I have to go to a training. So you guys are going to be doing an activity. This is why we need to rush through this so that you have this information for tomorrow's activity. So Desmos graphing calculator. Then you're going to scroll down and you're going to find statistics, linear regression.
Found it. Did you click open graph?
Just click on statistics, linear regression example. And then hit open graph. Yep. Okay, don't get rid of anything.
How far down is it? Oh, I found it. It goes in alphabetical order.
Statistics, linear regression. Okay, so you guys are going to like this much better, I promise. Promise. Here's the main thing though. Do not close out any of these parts of, don't X anything out. Just don't. Okay? What we're going to do though is we're going to get rid of the values that are on this T-chart here. So just go and just click on it and then hit backspace to get rid of all these values. Oops. You're just clearing them out.
Actually, I think I deleted part of the graph. I did. Yeah, same.
What do you mean?
You can just click the blue thing and mix another thing. The blue?
Okay, you guys can't get rid of this number 3. Do you see this number 3 down here that has a little exclamation mark? You have to have that there. So if yours isn't there anymore, you need to close out of the app and get back into it. Okay? It's okay. We're gonna need a lot. We're gonna need more than that. So don't worry about how many lines there are. Okay. So now you have this open. Put it to the side, and let's look at number 20. So the next page in your packet. It says the table shows the lengths and costs of several sailboats. Use a graphing calculator, that's what you have now, graphing calculator, to find an equation of the line of best fit. So that's what we were doing on our first two examples. We were finding the equation of a line of best fit. We found a linear equation based on a line of best fit. Okay? So the first thing we're going to do is we're going to take all these x and y values and we're going to put them into the table that's on this graphing calculator. Right? So all you're doing is you're putting the x's where the x's are and the y's where the y's are. So I'm going to put 27 for the first x and 94 for the next y. 18, 56, right? Do you guys see what I'm doing here? Okay, I'm going to stop talking so I don't confuse you. And if you need another one, you just click below it and it'll show up. You might need to zoom to see the line. You can zoom in and out to get a better idea of where the line is on the graph. So we didn't have to plot anything, and it made the trend line for us. Yay! It's our shortcut.
Wow. I know. Don't be careful though, because I accidentally did that.
I might have just done the same thing.
What'd you do?
I might have just moved my line somehow.
Yeah,
I did that too.
If you zoom in and out,
I zoomed out and I touched the line.
Yep.
It's messed up.
Yeah. Alright,
Okay, well, we've all learned a lesson.
Why doesn't mine?
Okay, so it says,
How do you do that? Yeah, mine doesn't look like that. Mine doesn't look like that either.
Yeah, the dots. Yeah.
I just plotted and left it alone. Okay, we have to move on. We're going to keep moving. Okay, so just use mine for now. Like, you know how to put the points in, you know what not to touch. All right, so if you look down here now, we have this number 3, right? Does everybody see this? It's got the little squiggle, this right here. Okay, this has very valuable information for us. It has the y-intercept, B, y-intercept. So for part B on our paper, it says identify the intercept and the correlation coefficient. We'll talk about that in a second. First, we're going to find, for part A, we had to find the equation of the line. So that's going to be y equals 4.8x. Hold on. Minus 37.7. So if you look here, here's my slope, 4.8. I just left it at 4.8 x. I mean, you're finding your way. And then my y-intercept is minus negative 37.7.
Where do we write down?
I'm writing it on the paper
No, okay.
like this. Y equals, and I think Jackson will feel better if I change that to 4.9. So I'll do that for, here we go. So here's A. Here's the equation of my line. Also known as my linear model, linear equation. They're all the same thing. Is everybody with me?
Yeah.
This is my answer to A. A. Okay. Is everybody good with how to find the slope and how to find the y-intercept? It'll adjust in a second.
I love that it just gives us the answer.
Right? It's kind of nice, but
It's sweet.
but you have to know where that came from, right? So if we hadn't done it ourselves, we wouldn't know where those came from. Okay, so part B says identify and interpret the correlation coefficient. This R value right here is the correlation coefficient. It just is. The single R value is the correlation coefficient. So what that means, so R equals, and we got 0.94, right? Okay. So this tells us there is a strong positive connection. Right?
How do you know that?
Because it's almost 1. So the closer it is to 1, the closer it is to having a connection.
Is it
And-
possible to be 1?
It's possible to be like 0.99. Yeah, it's never going to be actually 1 because you're dealing with different kind of data. But 0.99 is as close as you'll get to that. So if it was,
Is it possible for it to be negative? Like
it is possible to be negative. Like the closer it is to positive or negative 1, the stronger the connection. So think about it. The length of a sailboat is going to have a connection to the price, right? Bigger the boat, bigger the price, okay? If there was a negative correlation, like the older the car, the less value it has. That's going to have a strong negative correlation. If we were talking about number of siblings and shoe size, there's no correlation to that. You would not have a number that's anywhere close to 1 or negative 1, right? So if we were to plot that, there would be no connection. That has nothing to do with each other, okay? So when they ask for that, the correlation coefficient is that R value. Is everybody with me?
Yeah.
Kind of. Okay, so check off B. We finished B at the top. C says interpret the slope and y-intercept. Okay, well my slope is 4.9, right? So that is telling me that is the cost over the length. So it's going to cost $4,900 extra per 1 foot. That's what they're saying. It's saying that every extra foot of the boat is going to cost me $4,900 extra. Boats are expensive. That's why you know what the best kind of boat is? A friend's boat.
Oh, yeah.
You don't want your own boat. It's a lot of work. It's very expensive. Okay, so we're going to stop right there. We'll come back to D and E on Monday. Let's flip the page and do another one to make sure you guys have the system down. Okay, so on my graphing calc, guys, we had a deal. You weren't going to talk in between. We had a deal. So now we're on example 27, analyzing relationships. Right? Is that what it says on the paper?
Wait, we skipped D and E, right?
We did. We'll come back to that on Monday. You don't need that for tomorrow. Okay, so I have this. I'm not going to X anything out. I'm just going to get rid of these.
No, you can.
Do some tomorrow.
I was doing that every day forever.
You're just going to...
if you go from the bottom X, it'll delete everything faster.
Really?
Yeah, you just have to keep deleting.
Oh.
Wait, what?
Who figured that out? That is brilliant. Thank you.
Oh, no.
What do you mean from the bottom X?
Yeah, I don't know. No, you have to reset it.
Okay, so now I'm going to put in my X's and Y's.
X's.
Oops.
Zoom out. Or oh, you right.
Just don't touch the line again. I'm not going to do that.
You can't touch the dots. You can touch the line.
All right. So we What is my slope? What is my slope for this information, which we are comparing the grade point averages of students and the number of hours they spend watching TV? We'll just say like on their phone. What do you think, Addison?
0.3. No, negative 0.3.
It should be negative 0.08.
Wait, what?
Yeah.
Uh-huh.
Mine said.
Yeah, you're wrong.
Oh, but then mine's messed up. Then I guess. Mine says negative 0.307674. Let me
Okay.
check. Let me check out my.
Okay, we're gonna keep moving. What's my y-intercept?
3.8.
Plus 3.8.
I found where I messed up.
So here's my linear equation. Y equals negative 0.08x plus 3.8. Yeah?
Oh, I got mine now. Is it negative 0.083453?
Yes.
Okay. I had a different number plugged in for a while.
It's okay. All right, so this was my M, remember? And this is my B. All right, so then for, it says, find the equation, identify, and interpret the correlation coefficient. What is the correlation coefficient for this example?
Negative.
It's basically negative.
Negative 0.
Yep, exactly. So what does that tell me about the connection between the grade point average and the hours you spend distracted on your phones?
It's really,
It's a strong negative correlation, right? Remember, we're just trying to be really close to 1 or negative 1.
Oh.
So the closer you are to negative 1, that's a strong negative. The closer you are to positive 1, that's a strong positive correlation. If you're like around 0.2, there's no correlation.
Wait, so if you were negative like 0.98, that'd be.
Strong negative.
Okay.
Yep.
wait, what if it's 0?
Then there's no correlation. That means the two things have nothing to do with each other. Right? So what we've just proven is that, yes, the price of the sailboat has to do with the size of the sailboat, and your grade point average definitely could depend on, most likely depends on your screen time. Right? Okay.
Wait, it's no.
All right. So that was part A. Part B says interpret the slope and y-intercept. So we did this already, right? We did this with the boat. So I'm going to say M equals, and we have grade point as our numerator, screen time, hours. I changed it to screen time because, I mean, I don't think you guys actually even watch the TV. Don't you just sit and watch your little phones?
No. I watched it.
You watch TV? Yeah? Okay, so what we have here is our negative 0.08 over 1 hour. So that says that my grade point average is lower by that much per hour of screen time. Right? So that means that every time you are distracted during the week doing something, yep, grade point average. Is lower by that much per hour of extra screen time that you have. Yeah?
Is this true though? Because I was
What?
Is this true though? No.
I think it's more accurate than you would believe. Yes.
Because like I still have decent grades and I'm on time.
I mean, I think it depends on if you have figured out a way to manage all of it. Some students cannot. Okay, so we're going to skip C and D. We'll come back to that on Monday.